Ciao, Ben. Today we are going to talk about identifying quadratics. So we've done a lot of solving. Now we need to be able to identify them. So we need to be able to do that whether we're given an equation, a graph, or a table. So do make sure you have this paper before you start. No need to rewrite all of this. All right, if you are given an equation, it's a quadratic if it can be written in either standard form or if it can be written in vertex form. And reminder, both of these are on our formula chart that we get to use on all of our tests. But in case you forgot, standard is y equals ax squared plus bx plus c. And vertex is y equals a quantity x minus h squared plus k. And another reminder that's really important, y is the same as f of x. And when I say f of x, that's that thing. So y, f of x means the same darn thing. Just two ways to write the same thing. So if you got an equation, if you can write it like this or this, it's quadratic. And remember, either way, a cannot be 0. A can be any number other than 0. For graph, that shape that a quadratic forms is called a parabola. And please pronounce this correctly, otherwise you're going to embarrass yourself in front of other mathematicians. Parabola, not any other weird saying. And it looks like this. Either it can open up, like that. It's not a very even one, but you get the idea. Or it can open down, like this. So think of like if you throw a tennis ball, or if you kick a soccer ball, how it would go. Or if we're doing this way, think of a dish, like the satellite dishes that you see. So you just gotta look. If you got that shape, it's quadratic. For a table, you need to look at the second difference. And the second difference must be constant. Here's what I mean. Let's start with this table. First, before you look at any differences, make sure your x's are going up by a steady amount. So here we got -1 to 0, that's +1, +1, +1, +1. So our difference here is constant. Okay, then we can look at our y's. Going from -1 to +1, we have to add 2. Go from 1 to 3, we add 2. 3 to 5, add 2. 5 to 7, add 2. We call this our first difference. So since our first difference is constant, same number, this is not quadratic. Let's look at this one. Again, let's double check our x's. So it goes up by 2 plus 2 plus, oh sorry, by 1. 1 plus 1 plus 1 plus 1 plus 1. Awesome. So x is constant. Now we can look at our y's. To go from 6 to 0, we subtracted 6. To go from 0 to 2, have to add 2. 2 to 12, that's adding 10. 12 to 30, that's adding 18. So it should be obvious. This first set of differences, not constant. -6 is not the same as 2, 10, 18. So let's see if the second difference will make sense. To go from -6 to +2, we have to add 8. To go from +2 to +10, that's also adding 8. And then 10 to 18, that's adding 8. So notice the second set of differences is constant. It's the same number. So this table is quadratic. Okay, now that we know whether it's quadratic or not, let's talk about domain and range. I know we hate domain and range, so this should be review. There's a great poster, if you're in the classroom, look to your left, that should help you some. So hopefully this is a review. Okay, if you're given an equation, a quadratic equation, the domain will always be x is in the set of all real numbers. So remember, that funny R means all real numbers. For the range, the easiest thing to do is graph it on a calculator. Remember to imagine that it has arrows on both ends. Don't assume that just because our graph stops, that's where it stops. There's no way to show that it goes on forever. So we're going to talk about graph section on the back of this page. All right, finding the domain and range given a graph is a little different. If you have arrows on both ends, just like with the equation, your domain is x is in the set of all real numbers. Otherwise, we need to draw lines to the x-axis. And a little reminder, if you have circles like we have here, an open circle is going to use either this symbol or this symbol. Enclosed circles, colored in circles, we'll use this. Make sure they have the line underneath. All right, let's see what I mean. Okay, looking at first example. So going from the left, we notice there's an arrow on the left and an arrow on the right. Well, if there's arrow on both ends, the domain's easy. X is in the set of all real numbers. Next one's a little more difficult. So start on your left side and see where you first hit the graph. Boop. So I hit it right here where x is 0. Okay. Going from the right, well, we see there's an arrow on the right. So x can be close to 0 and it can be anything bigger. So we need to say that x is greater than 0, but notice it's not equal to because we have an open circle. Okay, this example, let's start on our left. Whoop, we immediately hit it right here at 0. And then on the right, it looks like we hit the graph again. Oh, sorry, I can't see that. On the right, we hit the graph again at 4. So we need to go from 0 to 4 for our x's. So we have 0 less than or equal to, because we have a colored in dot, x, which is less than 4 but not equal to because we have an open dot. One more example for domain. Okay, starting on our left, we have an arrow. And then notice going from the right, boop, we hit it right at 4 when x is 4. So that means x can be less than 4, can't be bigger than. So x needs to be less than. Ask yourself, can it be equal to 4? Yeah, we have a colored in dot, so x can be less than or equal to 4. Okay, let's try out some range problems. So for range, draw your lines to the y-axis. And remember that, again, open circles use these symbols. Enclosed circles use these. So let's go back and do the range for the 4 problems we just saw. Okay, so range is up and down. So let's start at the bottom. We first hit the graph right here. We draw a line to the y-axis. So y is 0. And it goes forever up. Notice how we have arrows, so it goes forever up. That means y can be bigger than 0, can't be smaller. And since it touches the graph right there, y needs to be greater than or equal to 0. On this example, again, similar thing happening. When we look, we touch right at 0. And then going from the top, oh hey, we have an arrow again. So it's going to have the same range as the first one because it's got to be, y has to be 0 or bigger. So y is greater than or equal to 0. Okay, these are trickier. So starting at the bottom, boop, we first hit the graph right here. When when y is 0. Okay, then going from the top, let's see if I can do this. It looks like it hits it right about there. So draw a line to your y-axis. I'd say that's about 68. Yeah, more or less. So we want to go from 0 to 68. So we start at 0. Ask yourself, what symbol should we use? Since that's an open circle, just less than y. And then less than or equal to 68, because it looks like it touches right where 68 is. All right, last example. Start again at your bottom. Ba-doop. It hits right there where y is 0. Oh, actually, I lied. I didn't notice this arrow at the end, so it goes forever down. My bad. And at the top, boop, hits right there. Draw your line to the y-axis. That's about 68. So y can be 68, it can't be 70, can't be 80, so it can't be bigger than 68, and it can be anything lower. So we'd say y is what to 68? What symbol do you think goes right there? I'd say less than or equal to. Okay, you should have another page with some practice on it. Make sure you just do the practice for today unless you're feeling crazy. Let me know if you have questions.